Hi, I'm Ryan Baker, and this is Big Data in Education. In this lecture, we're going to talk about something that's really big data, generative AI and large language models. Let's set the stage. I asked a large language model the other day, I'm a professor writing a MOOC lecture about large language models. How do I write a lecture that won't seem horribly out of date a couple weeks after I record the lecture, given how fast things are changing? Good question. As a large language model, I am pretty sure you are doomed. So what do you even call these things? If you look at the literature, you'll see a few different names. You'll see the names of specific models, you'll see large language models, but what about models of this type that are not language models? You'll see transformer models. That's probably the most common term for generative AI in the scientific literature on these models that are not language-based. You'll also sometimes see out of Stanford the term foundation models. I happen to like the term foundation models because it brings forward the idea that these models can serve as a foundation for all kinds of other analyses on top of them. And there are lots of examples of these models, including BERT, which was probably like the first widely used large language model, and MathBERT, and GPT-3 and 3.5 and 4, and maybe by the time you're watching this, 4.5 and 5 and 17, and Claude, and Mistral, and Llama, and DALL-E, and Stable Diffusion, and GitHub Copilot, and Falcon, and goodness, there's so many of these. And transformer and foundation models can be used to predict all kinds of things. Words, and sentences, and pixels, and computer programming text, and mathematical equations, and future life outcomes, and people say maybe anything. Increasing numbers of these models are also multimodal, which means they can predict multiple types of things at once, like words and pixels at the same time, and can handle or output multiple types of data. And what became fascinating is people developed all these sophisticated neural networks to predict all these things, and then at some point, somebody somewhere, and I actually don't know who, realized that prediction was the same thing as generation. And if prediction becomes generation, then machine learning can become prompt engineering for quite a few problems. For example, if we want to get a summary of how GPT works, we can ask GPT or another large language model that question, and if we do it in slightly different ways, or maybe not so slightly different ways, we get different outputs. We can ask it for a summary of how GPT works. We can ask it for a summary of how GPT works for a 5th grader, written at a 5th grade reading level. You'll get a much simpler explanation, both in terms of grammar and in terms of the ideas. We can ask it for a summary of how GPT works, written for a PhD in machine learning who hasn't read a research paper since 2017. It won't be dumbed down at all, but it also won't assume that you know the latest stuff. We can ask it to write a summary of how GPT works for a highly intelligent person who knows essentially nothing about artificial intelligence. This is going to give a very different non-dumbed down explanation. Or we can say, Ryan Baker is an Ivy League professor of machine learning. He's explaining to a general audience how GPT works, and he says, quote, "Here's a couple more examples from my group's work. Please revise grammar and style of this paragraph for a paper as a scholar without changing the meaning." We spent a lot of time iterating the sentence, and we find it really useful for helping us to make our papers more readable and enhance the quality of the writing. Here's another one. I am an explanation generation bot. I am trying to generate compare-contrast explanations for the graph I've chosen. Now I will generate 30 examples. I should make the sentence structures of these examples as various as possible. If you don't do that, you get 30 sentences that look super similar. I should not use words like while or whereas. Turns out that if you don't include that sentence, you get very pompous sounding explanations that don't sound like students. If you tell it not to write a pompous explanation or to write it sounding like a student, you still get pompous explanations that don't sound like students. But if you tell it not to use these two words, somehow it produces explanations that are clear. Broadly, there are two types of prompts. Request prompts, and those are typically used in chatbot large language models, and completion prompts, which are used in non-chatbot large language models. And I gave an example a couple slides ago where I said Ryan Baker is this person, and Ryan Baker is doing this, quote unquote. That's a completion prompt. Everything else I've showed so far is a request prompt. Large language models are based on text embeddings, and they represent text as a vector of features. So they take the words and they kind of break it down into a vector of numbers. So this two-dimensional representation shows if you were to think of words and small groups of words as being closer or further from each other, and that's actually on like a massively n-dimensional scale. But if you were to collapse it down to 2, Meow is closer to feline friends, say. Woof is closer to canine companions, say. And both of those are closer to each other than a quarterback throws a football. In using foundation models, you can prompt it, first of all, most simply, with something that's called zero shot, where you just ask the model to do something. Or you could do something that's called one-shot prompting, where you give one example and you ask the model to do the same thing. Or few-shot prompting, where you give several examples and you ask the model to do the same thing. Or fine-tuning, where you retrain the model with examples. And we're going to go into more detail on all these things later in the week. Another approach that's used by the developers of large language models and foundation models, and you can simulate it yourself using fine-tuning, is reinforcement learning with human feedback, where you give a model thumbs up or thumbs down on its outputs and encourage it to produce things more like the thumbs up, less like the thumbs down. So there's a rich variety of things you can do with large language models and a number of ways to work with them. And we're going to go through this through the rest of our week. And this leads to what you could call the elephant in the room, which is, and some people have said to me, why do we need this class anymore? Why not just replace this class in this video textbook with a class about foundation models? The reason is because when they succeed spectacularly. They're so impressive. And they've been out for a little more than a year and a half in their chatbot versions at the time of this recording. But even though they still impress the heck out of me, they can't do everything. And actually, they don't do most of the things this class has covered. And when they fail, they sometimes fail spectacularly. Right now, it seems like every week a new model comes out claiming to be the best at something. And there's a growing number of competitors releasing different models of radically varying quality. Some of these models are open source. That's a big advantage in terms of long-term reliability. OpenAI has a habit of completely deprecating older models and changing their base prompts without notice. And this has been a nightmare for researchers interested in reproducibility, replicability, and long-term stability of the tools built on top of the models. The rest of this week will represent deep dives into specific methods for working with large language models, prompt engineering, using embeddings, and fine-tuning.